Draft Science video. Response to a off-the-day comment. Yeah, I know. We'll see how it goes. Alright, well, I'll read it and I'll just do the... I think I can illustrate the problem. Why you? I don't like that much. Stress over Huygens Fresnel principle. Fresnel. It's a classic theory, not a quantum theory. Well, I don't agree, fundamentally. I mean, Huygens was obsessed with wave theory. He was one of the first quantum theory type advocates of this whole, it's a wave, it's not a particle thing. And clearly, the contrivance of Huygens is merely to somehow push the single slit experiment into the double slit experiment, to somehow make the two mathematically the same. And that's all Huygens does. If you use Huygens in the double slit experiment, you'll end up with 4 photons interfering with each other, not 2. So it's not a principle, because it's not applied consistently to all circumstances that are alike. All slits aren't alike, so therefore it can't be called a principle, because obviously the only time they apply it is when there's a single slit and they need to create a second photon. Alright, QM has wave states as superposition states. So I don't really care. The point is that it's this idea of something being in more than one place at once, which is silly, in my opinion, just grotesquely silly. No substantial evidence that anything ever does that. So why have a model that isn't correct? End of. I don't know what that means. A vector space, if you like, as I've made videos about. Well, again, a vector space doesn't mean anything if you don't regain the momentum that exists now in bent space. So I'm just saying that having a vector space idea, or just making a huge field out of all of reality and assigning all locations to a plus minus vector in 3 dimensions, is fine, sort of. But you have to acknowledge where that momentum came from. And there's the original quanta, or what gave it momentum. And that it all has, there's no such thing as a neutral space, theoretically. There's just one being balanced by equal agitation. So there's no such thing as a non-agitated state. There's a space. There's just spaces where there is a balance of force rather than an imbalance. It is philosophically untenable. Well, again, it says you. I'm saying quite obviously it's quite philosophically tenable if you just accept the fact that the original universe is made of quanta, not matter. But no QM physicist is advocating Huygens. Well, again, I'm just going based on every single documentary produced describing the 2-slit experiment and the single slit experiment especially. They all use Huygens. You can go to whatever the Microsoft, the guy financed by Khan Academy, he uses Huygens. Huygens is always used to mathematically describe the single slit experiment. It's the only way they can make the experiment mathematical. It's the only way they can do quantum mechanics on the single slit experiment is to Huygens it, because obviously on its face there's nothing making the second photon. There's no second opening to create a second photon. So they have to contrive one. I mean, I've made this point over and over again, and I just think it's kind of bogus to sit there and keep bringing it up like I didn't bring it. I haven't stated this over and over. So, yeah, I mean, bullshit. So anyway, I shall draw and illustrate, hopefully. So, we have 2 things. And then we have the idea of the double. We'll do the double over here. And, well, I should have made that bigger. Okay, never mind that. Yeah, cross that out. Yes. I just need to make the openings bigger for the illustration purposes. Okay. So I'll use a different color and everything should be fine. So let's say this was a single slit. What I would argue is taking place is there are these field lines that everything creates, because everything has some kind of charge property, in the sense that everything has protons and neutrons and electrons in it, and that creates a inverse squared, relationship. But the energy doesn't go away; it just weakens as it goes further away, and that kind of thing. But this is the idea that you would have these bends in the field energy. So it's straighter here in the middle, and it's more angular on the sides. And I'll get to the angular part in another drawing. But yes, I'll attempt to illustrate what these lines really represent. They're really not curved lines. They're really geometry, polygonic kind of stuff that magnets would do. So anyway, so in the double slit, the differences, so you see this idea that the two converge and that's all it is. Well, in the double slit, you've just changed the relationship in the sense that you're creating this this second object that's going to create these lines. And so instead of having just these field lines come into each other and meet and go straight, you have this circumstance where both sides are doing that. And this single impediment, it could be a very small impediment, it doesn't matter how big it is, it will automatically create this circumstance where it's going to create this thing in the middle that has field lines. And that's different than this, quite obviously. You can see the difference. And that's really what's taking place. So let's talk about what's happening on these field lines. And what I would argue is that these are, you can't, even in a vacuum, electrons still exist. You can't pull them out because the whole point of electrons is they don't like each other. And so they sort of spread out by consequence of that. It's not that they don't like each other. They absorb each other's radiation, which means they absorb the momentum the other electron is exuding in the same polarization as them. And that's causing this displacement. So I guess the first thing to understand is the back and forth ideas. So an electron would be little bits, little quanta. They're not moving in circles, they're just moving back and forth. And this star would have 3 dimensions, so it would end up being a sphere of stuff going back and forth. So the field energy is coming in, and it's reflecting off of it. So the field energy comes in, anything coming at it hits, goes back the other way, hits, comes back the other way, hits, and that this density is the same density, and that's why the electron is the size it is that it can only be the same density as the field energy itself. Arrow for arrow kind of an idea. And that the only way the electron could get bigger is there would have to be fewer of these little green things to knock it back in. So if you had fewer greens, then these blues could go bigger. But they have to be this size because of the amount of pressure that comes into them. And so that's basically what's holding it together. But these represent the vectors of direction. And these arrows can be traveling in different orientations, I would assume, not just through the center, but there could be ones that are going back and forth this way. Well, I should have done that in blue, but it doesn't really matter. So different lengths of arrow could also be in here, and such, I think. They're not different lengths. They're in different positions. So it's not like it's a perfect circle. So I guess the point to illustrate would be is that they can be quite eccentric to each other at any one point. They can be, this one can be going back and forth this way, this one's going back and forth this way. So they're the same length, but they're moving in. So this circle obviously wouldn't be a round circle for that exact moment. But exactly some other moment, it'll be exactly the other side. So every moment it's changing. You can have a funkier shape, but the end result is that over a period of time, it'll end up being a sphere. It'll average out to a circle. and that something that gets too far out of this probabilistic range, whatever this number would be, something that gets too far out of the bubble of acceptable would end up free. So this would end up escaping. If this arrow comes too far off of this arrow, if it loses the center of gravity, so to speak, connection to the center of gravity, we could almost argue, then it will escape and no longer be part of the electron. Okay, the polarization will escape, and it'll be replaced by foreign bits, if that's all there are, and the foreign bits will be the green, to illustrate. So anyway, so that's the nature of the electron. So the point I would be arguing is that around these slits, the electrons are spaced, but they're held in a magnetic grid. They always will find a tension between each other and be equidistant from each other, in the sense that they all are force communicating. So they're basically saying, yeah, you're far enough away, yeah, you're far enough away, and so if they're closer to one than they are the other, they would end up balancing between each other. So they're always going to tend to line up comfortably at a certain distance, and there'll be uncomfortable distances. So when they're free, they're obviously at a very loose association. They're almost at the fringe of communicating with each other at all, of even feeling the force from each other, because they're basically free. They're under no tension, no compression. So they're basically just saying, I'm content to be here. But if I move one, if I hit this electron in a Feynman kind of way, a photon comes in and gives it acceleration this way, then it gets closer to this one, and both of these will become uncomfortable. But the real point is this one's going to communicate that extra momentum, that velocity, that acceleration. And so this acceleration is going to be suppressed because this one's going to say, I don't want you getting closer to me. And so the field energy is going to create a pressure here. That pressure will be felt by this one, and he'll send the photon this way, because that's his orientation to his neighbor. So his tendency to be force connected, his gyroscope is oriented in this direction, where this guy's gyroscope was oriented in this direction, if I could use that terminology. So depending on the force tension, the gyroscope, the place where they will emit the force vibration, is consistent with their alignment. And so for each one, that arrow will be a different arrow of who their partner is. And it'll always be a specific degrees of separation. It tend to be. And that accounts for why you have a pattern that has a specific orientation to degrees that's connected to the amount of energy that went in. So depending on how much energy goes in, what frequency the light is that hits it, will decide, in essence, how what this vector is. This angle of tension is going to be decided. See how to put that, by the frequency of the movement. So it's the geometry, instead of the geometry being on the slit, the angle theta thing, it's really here. In terms of this angle is the angle that's going to be decided based on how aggressive the movement is, because it's going to be moving in two directions essentially. So if the force hits it straight, there's going to be that force plus the addition of the force, in the sense that it has this bonding relationship. So the point is outside of this field line, this is the neutral line. So meaning that if you took a neutral a charge, it would always leave perpendicular to this line, in the sense that the force is balanced on that line. And the this momentum is obviously not going to be balanced, in the sense it's going to be off of that that balance line. So as soon as the electron travels in this open field, then it's going to be feeling the pressure from the thing creating the field line to reorient itself back to the field pressure. This pressure now will be stronger from the field. The field will push it back into the alignment, and that's what I'm saying is the energy of why the frequency is dictating how strong this angle is. So how strong the angle of the bonds between these things. So it really doesn't, nothing moves in a straight line. Everything moves in the vector line of a certain component in the x direction, a certain component in the y direction, and then a certain component in the x direction, and a certain component in the y direction. So everything's moving this least line internally. That's the internal thing. So even though it looks from our perspective like it went this way, it really did this internally. And that's what I'm trying to get to. And this is what's going to be frequency dependent, in the sense that this frequency here will dictate how far it travels this direction, which will decide how this line and this line and this, you can see how those lines are decided by how much you go into a field will decide how the field will be stronger, pushing you back. So it'll always end up being a staircase, but it'll just be bigger stairs as the frequency increases. Yeah, it's probably a better way of saying that. But there's not a one-to-one relationship, which means that's what accounts for the fact that there's a different, like red light will create a bigger angle, blue light a smaller angle. Yeah. So what else did I want to bring up? So anyway, so you can sort of see that the difference between the single slit and the double slit, you could sort of account for it, in the sense that you can sort of understand that if you took just the stuff coming out this end, and you just said, okay, let's not count accelerations that might happen here, where it would deflect this way, because that's just going to confuse us. So let's just use these outgoing ones. And if you just thought of these as angles, the field line producing angles, you could sort of get the idea that that's the filter right there. That's what's going to create this bar pattern, is these angles. And as you as you compress the slit, these angles will become more eccentric. Okay, the field lines will have to, compress, and so they become more bent, and so your pattern is spread out more. And the further away the wider this opening, the more these angles relax, and so now the angles get tighter and tighter. So the bar pattern gets smaller and smaller and smaller as you widen this, because the field lines get more and more relaxed. So you end up with a tighter pattern. And you can see in this, obviously in the double slit, because you have this impediment in the middle, you're creating these extra field lines here. So now you have angles going this way, like here, and angles going this way, like here. Okay, but you have these internal converging angles that cross each other and add to the pattern. So these are the two things creating the pattern. The two patterns being superimposed on each other are this pattern and this pattern. So these are the two components. These exterior are creating the bars. The interior is creating the bulges. Or vice versa. I'll have to figure out which one is which. I'm just trying to think if I can think of which one is which intuitively off the top of my head. Yeah, let's see, can I? Well, I can't do it right now, but I'm just saying one of these is creating... So the two-slit pattern looks something like this. And then and then and So it's big in the middle, smaller, and then smaller. So there's two patterns. There's this pattern, and then there's the bars inside of that. So that's what the double slit produces. So what I'm arguing is this interior thing is doing this part, and this outside part is doing this part. Kind of. So yeah, so I don't know if I think that's, maybe I'll just keep this brief into this point. But I did want to sort of get to the point that when you move an electron, this is something this is a hard thing to illustrate, so I haven't figured out exactly how to illustrate yet. So you got this idea that the components are going back and forth, and they're going back and forth based on the field pressure, so they do it irregularly. Before this one hits something, it goes a little further one time, it goes a little less another time, and then it's reflex. When it hits something again, it can be a longer line, it can be a shorter line. So we just think of this as being one thing bouncing back and forth. So it can bounce, it can have a long bounce or it can have a short bounce depending on the field energy that it hits. But over time there will be a consistent rule about where and when and how it's going to hit one of those force lines. And the fundamental rule is that if I start moving in a direction, that is, I add extra force going this way, then I'll end up going, so if I add more blueness, that means this thing hits something sooner than it would have, or it uses up that green arrow, and now there's no green arrow to hit this one, if you sort of understand. So if I add a new one, a new little blue in here, there's going to be an interaction now that's going to get used, and that inevitably the next arrow that would have come up is going to go deeper into the field. So it goes deeper this way, and that consumes a little bit of time in a sense, which means that the field energy from the other side, okay, since this is consuming more time, it went deeper into the field. That's like a longer arrow. This had a little more time to get a little deeper, so now the field energy is incurred into the other side because this hasn't reversed yet. And so until it reverses to come back to hit this other green coming in, you see, if it takes longer for it to do a reversal because it went deeper this way, now it's going to take longer for it to come back here to hit this one. So this green one gets to go further in before it gets hit. And then obviously it's getting hit here, which is a much higher location, like only halfway in. And so therefore when it reflects, it's going to end up here. It's going to end up going deeper into this again. So that's the nature of velocity. So the nature of velocity is really something like this. Okay, it's that's what the effect is like. So it has a tendency to go more in the one direction because of the time change. So it did a little more time this way, means that this time will be affecting your rebound time, and your rebound time is what's going to keep pushing you forward continually. So until you have an extra blue to get rid of that green, then you can go back to being neutral in terms of where the up and down part, the up and down won't be doing the inner direction thing. And so once you understand that, then you can sort of understand that if something starts, if an electron, one of these things that just has all this back and forth stuff in it, if it starts to move in a direction, it's going to essentially, there's stuff going this way, back and forth this way, and there's also stuff going back and forth this way. Okay, so the problem is that if this end starts to do this, going in this direction, the stuff going back and forth, all of a sudden this is going to leave, and this is no longer going to be part of the electron. It's going to be ejected essentially, because the center of gravity, if we just say this is the center of gravity, the center of gravity, center of gravity, center of gravity, the center of gravity has moved away, and now this is no longer going to be retained inside of the the thing, the spool, so it's going to be detached. So it's still going to go back and forth a lot. Okay, it's still going to be kind of stuck in the same I'm polarized, I keep bouncing off. It's going to keep doing back and forth, but it's going to be doing back and forth, not part of anything anymore. Well, that's probably not the right way to say it. It's going to do back and forth. It's going to do back and forth, but it's going to do it in the field. And obviously in the field it's going to reflect off other things, and those other things are going to end up going this way or that way, depending on which way it was released. So it's wrong to say back and forth, because it's obviously at the point of release it's only going to be going one way. So technically there won't be any back and forth anymore. And when it goes that one way, it will hit other bits and reverse their direction. So a bit will come in and get reversed. And that's the nature of the field energy produced by the EMF produced when electrons are accelerated. So when the electron gains in balance, so when it goes from this to this, at that moment it will lose stuff going this way. And so a piece of stuff going that way will be released into the field again. Yeah, so I just have to get the polarization part of that correct. So the real catch is, to understand this, is there's a mechanism I haven't discovered yet entirely, whereby a specific polarization is held in an electron, and a specific polarization, which will be the red, but I don't have a red marker at this moment, so we'll just use green because that's what I have, or black. We could use black. So the electron will be blue, the proton, black is running out, would be the black, and these polarizations being the same polarization means that if you emit one of your blues, because you accelerated and a blue came out this way, what that means is that another blue guy over here, this blue will end up being absorbed as part of its identity, and now it will do this thing. It'll do this. It'll jerk its way in this forward direction, and so it looks like it's repulsed, but it's not really repelled. It's just accepting your gift of velocity, your gift of acceleration, and now it's accelerating away this way, and in doing so produces a force this way. So that's the trick part. So the force that caused the initial problem was this way. This created a freedom this way, and then this one will create a freedom either that way or this way. So it always balances out in the end. The equal but opposite reaction ends up being this arrow to this arrow. But it took a couple of interactions to get that arrow. Something like that. So anyway, yeah, I don't want to get too... I think I got something basic here for you to feed on. But again, so the Huygens argument, though, again, if Hofstadter wants to point me to a video where they use Huygens in the double-slit experiment or the three-slit experiment or some other experiment besides single apertures, and explain how the principle is used in any other circumstance besides to convert single slits into something capable of producing two photons, because that's all it exists for. The whole point of Huygens and the waves is to create an excuse to create two end points and make the end points now individual photons. So that's all Huygens is for. They negate all the little infinite number of wavelets. They mathematically extract all of them except for the end ones. And now they have two photons. And that's all it's used for, is to contrive two photons in the single slit experiment, where you don't have an obvious source of two photons. And again, if you're going to use Huygens here, you have to, if you're going to call it a principle, you have to use it here and here. So how come this Huygens, this doesn't Huygens? There's no reason why this should Huygens and this shouldn't and this shouldn't. There's no continuity or logical reason to say, no, Huygens just doesn't happen there. There's no explanation how the two-slit experiment knows not to Huygens. Okay, that's probably the best way to say it. But I have already said it, so I don't know how to say it any clearer. Show me, okay? I mean, I'll show you. I can give you a link to the. I already did the Japanese woman doing the math, and clearly the single-slit math only works with Huygens, and clearly the double-slit math really describes the pattern you see in the single-slit, in the sense that the math describes a consistent amount of bars, a consistent distance from each other, and it doesn't account for this double pattern at all. Truth. Okay, so I think that's enough. Hopefully you've followed some of that, but I'm just saying this is good. This stuff is I think this is pretty close to how it's going to turn out. But this is how it sort of is. So I've gotten really close now. Anyway, till next time.